Hey everyone, Sebastian here back with a fun math challenge for you all. So we have this square, right, circumscribing a circle. And we know the side lengths are 8. Now can we find the area of the pink, right? So it's pretty straightforward. What you want to do is find the area of the square and subtract from it the area of the circle. So if we're going to do that, right, we're going to do, first let's find area of the square. Area of square equals 8 squared equals 64. Okay, great. And now let's do area of circle. So first we need to find radius of circle, right? So it's going to be something like this here, right? We have a line drawn out to it. That's half the distance of the whole thing, so it's going to be 4. So then area of circle is going to be of circle will give us, remember it's pi r squared equals pi times 4 squared, which equals 16 pi. So your answer right will be area of pink equals square minus circle equals 64 minus 16 pi. And this is one way to write the answer. This is often we have a multiple choice test with this type of question. They'll just have the answer like this. I see that with a lot of my students' questions and tests. But also if you wanted to find it, you could do 16 pi. So you could do an estimation, put this into your calculator or work it out like I'm about to. 6 times 4 will be 24, so it's a 4. Carry the 2, bring it down to get 8. 6 times 3 is 18. And then you're going to find here that you'll do the same with the 0 or the 1. So it's you add a 0 for that place, and then you get 1. And then what happens is you're going to get 4, 2, carry the 1. So it'll be 0, carry the 1. Will be 5. So we have 50.24. So then area of pink would be (64) minus 50.24. Obviously that's an approximation because pi goes on forever. It's going to get you 13.76. Right, and that is here. All right, so now we'll go on to the next question, which is basically this question a little more complicated. Okay, pink area. So I already found the one outside, but the numbers are different, right? So we're going to do 12 this time. And then from 12, we're going to do the rest of it. So all right, so in this one, right, we're gonna find the area of the square inside and the areas we just did. So the outside part we already did. Different numbers here with 12, but we can work it out. And then we'll find the area of the inside. So actually, I'm going to start by finding the area of the inside because that's the more new and exciting piece of information, right? So it's going to be, was it bad? Bad diagonal there. Okay, so that is going to be basically the same length as the radius, right? Which would be, we found it before, was half of 12. So this is going to be 6. And then that means that this is also going to be 6. Right here. Right. Okay. So then that means the diagonal of the square, right, we drew it all the way out, is 12. Okay. And then that means that we have, this is a square on the inside, right? It's a 45, 45, 90, because it's all an isosceles. So that means that this 12, we can do Pythagorean theorem or know that special right triangles, right, 45, 45, 90 rule. Special right triangles is going to give us the value that we're looking for, right? So 45, 45, 90, if you don't remember. (45, 45, 90) means that across from 45 degrees, you have the legs, which are x and then across from 90, we're going to have x root 2. So if x root 2 equals 12 here, right, because that's the hypotenuse, 12, that means x equals 12 over root 2, which what I'll do from there, right, is multiply both top and bottom by root 2. And then you're going to get x equals 12 root 2 over 2 equals 6 root 2. Okay? So now we know that it is 6 root 2. We're going to label that over here. Six root 2. Okay, and now we're gonna work on the rest of this. I'm just gonna erase the stuff we did here. So area of square, pink square is gonna be, so I'll call it small square. Equals 6 root 2 squared. Equals 6 squared is 36, root 2 squared is 2, so this equals 2 times 36, which is 72, which is great. And then we're going to do area of the pink on the outside, right? Which is right here. This, and this, and this, and this. And then we're going to do that by doing what we did last time, right? So big square is 12 times 12. Alright, so now we find area of circle and we take that away from the big square. So area of circle is going to be equals 6 squared times pi, which equals 36 pi. Okay, so you could do area of big circle plus area of small circle, or area of big square. Okay, so you can do area of big square plus area of small square minus area of circle. So that's what we'll do here. 144 minus 36 pi plus 72. And that's going to get us 216 minus 36 pi. And that could be an answer, right? Or you can do 36 times 3.14 to find it, right? If you did that, I'll do it up here, right here. Right? One 4 times 36. So again, we got 4. All right, so you're going to do 4 times 6, right? You're going to get a 4 here, carry the 2. So it's 24, so that's going to give you an 8 here. 6 times 3 is 18. So just like last time, right? Then we have a 0. 3 times 4 is 12, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Then you're going to get 4, 0, carry the 1. 12 plus 1 is 13, carry the 1. 9 plus 2 is 11. And then we put it here. So it is 216 minus 113.04. And that gets us 102.96. All right, so if you have any questions on this question or the one before, let me know. These are just fun geometry practice questions that are, little brain teasers that I like to do sometimes with my students. And I hope you all have a good rest of your day. Bye.